In the modern enterprise, valuable data is often restricted to specific departments and systems. This fragmented architecture fails to provide the greater business context your decision makers require. The Customer 360 view offers a more holistic approach to managing your internal and external data. Our intuitive data management platform allows you to extract, match, validate, and consolidate data sets with inputs from multiple business channels and varied sources, both from within and outside the organization. The result is a centralized, customer-centric repository which can help you create cohesive business strategies based on contextual and timely data. Building a Customer 360 data architecture in Astera Centerprise. Let's discuss some of the advantages of constructing a 360 data view in Astera Centerprise. First, data collection and extraction from disparate sources such as Excel workbooks, delimited files, database tables, and even APIs. It makes smart transformations to perform aggregations and remove duplications in the data with supported transformations such as aggregate, denormalize, join, sort, and various lookups. Next, it can also load data into a consolidated database or visualize it in the form of reports so that you can gain real-time integrated insights into internal and external data accessible across the organization. And lastly, identify trends and underlying patterns that allow you to plan and execute optimized business strategies. In this video, we will look at a use case from an auto insurance company to see how 360 Data View can benefit organizations within this industry. Insurance companies have comprehensive data reporting processes and analytics, with data coming in from varied sources, both from within and outside the enterprise. They use these diverse sources to track customer profiles, purchasing behaviors, customer service channels, and similar tasks. All this information powers data-driven decisions. The outcome is more effective marketing, more engaging customer experiences, better products, and the ability to stay ahead of market trends. Insurance companies must examine data on claims, policies, average premiums, safety guidelines, marketing insights, damage control summaries, etc. All this data comes in from various sources and needs to be put into a central repository to create a 360 data view for the organization. Let's see how Astera Centerprise can design a solution for an auto insurance company. So, the first thing we need to do is get in data from our various sources. We have a data flow where we're going to get data for insurance claims. We have our data stored in an Excel sheet. From the list of sources in the toolbox, we'll drag and drop the Excel workbook source object onto the data flow designer and get the insurance data into Centerprise. Once we have the source configured, we need to get more understanding from our data. We'll use some of Centerprise smart transformations to accomplish this. First, we need to check how many cars in the data are older than 5 years and get data for those cars which are not older than 5 years. To do this, we'll get an expression transformation from the list of transformations present in the toolbox. In the properties of the expression object, we'll create 2 new fields and give expressions for each one of these fields to get the outputs required. For one field, we will apply an expression to get a list of cars that are of model greater than 2010. And for the other field, we will apply an expression for all the cars of model lesser or equal to 2010. Next, we'll perform some aggregations. We'll get 2 aggregate transformations and map the output fields that we previously created from the expression object for vehicles that are older than 5 years, and in the other one for the vehicles that are not older than 5 years. For each of these aggregates, we'll group by the state and sum the greater or lesser model fields. Let's preview the output for cars that are of older models. We have a count of cars against each state. Data from both aggregates can now be written to a destination for departmental use. For further aggregations on the data to get more insights, let's get another aggregate transformation onto the designer. We'll use this aggregate to check the highest number of claims made on a policy in a state. We'll group the state and the policy type and count the policy type count field. If we now preview the output, we can see the policy count for each state against each policy type. Since this data can be grouped further, we can denormalize this data using the denormalized transformation. We'll denormalize data for each of the policy types: corporate, personal, and special. In another aggregate transformation object, we'll compare the sizes of vehicles against each state to see which size has the highest claims in a state. If we preview the output, we can see that we have the vehicle count for each vehicle size in a state. Since this data can be grouped further according to the size of the vehicle, we'll denormalize the data based on the vehicle sizes: large, mid-size, and small. Let's perform one last aggregation to check average claim amount for each state. We'll group by the state and average out the total claim amounts. In the output, we have the average claim amounts for each state. This data can now be written to a destination of choice for further use. We now have to send the data integrated for claim policies and vehicle sizes to our Customer 360 database. We'll first use a join transformation to join the data coming in from both the denormalized transformations with the state field as a key field in the data. Now, this data can be written to the centralized Customer 360 database. We have now created an integrated data flow for insurance claims. Let's open a new data flow to integrate the marketing data for insurance. Once again, our first task is to pull out data from a relevant source. We'll get the insurance marketing data set onto the designer using the delimited file source object. And to integrate this data, we'll also get the insurance claims dataset that was also used in the previous data flow. We'll use a join transformation object to join relevant fields from these datasets which are required to perform further data transformations. Once we have the data joined, we can now perform various aggregations on this data so that it becomes more useful for the analysis in the Customer 360 view. The first aggregation is to calculate the average ages of customers filing claims in a state. We'll group by the state and apply an average on the age field. In the data preview, we have average customer ages from each state that receive coverage from the auto insurance provider. Next, we will perform aggregates to check the educational level of customers making insurance claims so that their marketing strategies can be fine-tuned further. We have a count of customers against each educational level. This data will be denormalized further to get it flattened according to the educational groups: associate, college, high school, JD, master's, MD, PhD, etc. Another aggregate will be used to check which sales channel is used in each state to purchase insurance policies. In the output, we have the count for each sales channel that is used in a state. We will denormalize this aggregated data to group it according to the sales channels: agent, branch, call center, and web. Once we have the educational and sales insights denormalized, we will join this data to get collective customer demographics, with state as the key joining field, and write this joined data to our Customer 360 database. In a new data flow, we will integrate data from damage control section. we'll get the dataset for damage control using the delimited file source object and another dataset for damaged area codes of a vehicle using an Excel workbook source. We have coded values in the damage control dataset. To decode these values, we will use a file lookup object from the transformations in the toolbox and map the field state case to get values against it. Once we've matched the primary field names, we'll apply a count to determine which areas of a vehicle are damaged most often during accidents. To do that, we'll get an aggregate transformation and map the field's state value from the lookup and the area value for the damage control dataset. Now, to get the description of the damaged areas, we'll join the data in the aggregate with the area key codes dataset using the join transformation. We'll further sort this joined data in an ascending order using the sort transformation. Next, we'll denormalize this data to get inputs for damaged areas that are clock points, top, undercarriage, damage, left, and unknown. If we preview the denormalized data, we have damage count for each damage type sorted against each state. This data can now be sent further in the Customer 360 database so that they can fold these patterns into their actuarial analysis and policy decisions. Finally, let's bring a real-time element to our data. In a new data flow, we'll get the insurance claims data in an Excel workbook source to check it against real-time data for safety ratings from the National Highway Association. In order to connect to the National Highway Association database, we'll use a REST API client object. In the toolbox, under the Services section, we have the REST API client object. We'll drag and drop it onto the Dataflow Designer. Let's see how the REST API object can be configured. In the properties of the REST API client, we'll set the HTTP method first. The supported HTTP methods in Astera Centerprise are get, put, post, delete, and patch. For this API, we'll set the HTTP method as get. Next, we'll provide the base URL for the National Highway Association and define the resource according to the requirements. We need values of safety ratings of a car based on its year, date, and model. There are other configuration options where we can define the layout format, sample layout text, service options, and more. Once we have the REST API client configured, we'll map it to an expression transformation object to flatten out the data so that it can be written to our Customer 360 database. If we preview the data for the expression object, we can see that we have the vehicle description returned for each vehicle ID with a safety rating from 1 to 5. Let's write this data into our Customer 360 database using the database table destination object. We now have an API-sourced data written into our Customer 360 database, which can be used to set insurance claims, premiums, and policies better. Now that we have collected, aggregated, integrated, and consolidated data from various sources and written it to a central Customer 360 database, the final step is to automate the entire process for all these data flows. We'll open a workflow in Centerprise. On this workflow, we will define the sequence in which the data flows will be triggered to run depending on the nature of inputs. In order to make the data flows run, we would need to get these data flows inside the workflow. To do that, we will use the Run Data Flow object from the Workflow Tasks drop-down in the toolbox. We'll set up the Run Data Flow tasks for all the 4 data flows. The main data flow for the insurance claims is set to run first. Then we have the marketing and damage control data flows run next. And lastly, we have the API-sourced data flow for safety ratings to run last. Once all the data flows have been run, we'll add a sendMail object to receive an email upon completion of the run. The last step in automation of this entire process is to schedule it on the job scheduler in Astera Centerprise. In the main menu, Server option, we'll open the job schedules. We will set the schedule to run on file drop for the watch folder that we have given. There are other scheduling options as well that you can choose from that is relevant to your process. And that's it. We have successfully orchestrated a process for insurance claims that is directed to a Customer 360 central repository. We can create a project for this entire process and save it for later use. From the project option in the main menu, we will open an integration project and add all the data flows and the workflow into the project. Thank you for watching this video. Feel free to reach out to us in case of any queries or visit our docs site.